Here we go again, same test. Now what I did is I brought this up a bit, the accel to 4,000. I left this at 1,000 just not to limit the speed, and then the axle to diesel at 3,000. Alright, I know that for the weight, actually it's not speed, but it's the acceleration that has been giving me trouble. Let's see, if I had this before and I was having a little bit of trouble, but I was going slower, and believe it or not, there is some points where going slow, it kind of like the axis gets stuck, like they don't flow as good. And then when you go over that maybe resonance, that gets, it goes a bit faster. So let's see if at 400 with 4,000 axle it doesn't give me any trouble. So we're gonna do the same test, and then we're gonna start tuning the speed up from 400. Might be also later getting a PT 100 just to see if I can get the hot in a bit higher temp, so maybe I can extrude a bit hotter just to go faster with the extrusion. But maybe with that new nozzle that I ordered will be enough. I just ordered yesterday, so I have to wait a while so it gets from China to Chile, because actually I'm in Santiago, Chile, so not close, halfway around the world. Okay. Some guys were asking me about what mods I had here. So actually what I have here is, I have this, I'll have to get everything together, but this is actually a mod that you can get from Thingiverse, and that holds the Raspberry Pi here. What I did add is I have in the bottom I put that power supply or converter that steps down from 24 volts to 5 volts for the Pi. I'm looking maybe, but I just don't want to get into flashing anything again, because it wasn't really easy, so I don't want to mess with that. But this cable here bothers me a bit, the USB on the back. Maybe do an UART connection at some point. So what I have on the mods is the cable chain that's updated. Then I got the camera here with the O-ring and with the LED ring, and then the same LED ring RGB LEDs. I have them here. Those the other flip knockoff LEDs things. And then what also I have, well, now the two motors, but also has a tension system here. The temperature seems to be good, so I'm fine. Here on the back, I have that. That's like a standard, like kind of like those old switches, end stop, and that end stop has a bit from Allen bit for this cordless screwdriver. So I have that, and it just kind of fits, and I put it there. First it was a bit closer, but then I had to move it a bit back. If you do this mod, make sure it's not too close. You don't want the heat creeping into this, because you want to have a steady, alright, here we go. You want to have a steady size for that card, so it doesn't matter what temperature you're printing, it won't vary. Alright, so this is 4,000 axle. It sounds a bit harsher, but it's holding fine. So what we're gonna do, let's start bumping the speed up. Let's go 10 by 10 again, because I don't know with this axle how it will behave. So there we go, 10%. Now there is no limit for speed on the firmware, so I actually put 1,000. So actually a meter per second is the limit. I don't think we will reach it. Alright. I you can tell that it's working by how the sound changes every time you increase the speed. Okay, you can see the pitch of the sound, how it changes. Alright, and press. Go. I know this has like round corners. Probably with square corners the behavior could be should be different. It's gonna be a bit harsher on the printer. That's why I use round corners. Let's go 140%. In theory, we are close to 600 now. That's way more than, I don't think any Prusa could get to that. And you know what? It's extruding fine. I mean, not perfect, but it is extruding. Let's check the temperature. The model is holding up fine. Alright. You can see all the sound changes. Now we are at 600. We should be at 600 actually, but going. Now we're gonna go like, now we're going really fast, so I'll go like only 5% at a time. Extrusion is not holding up, but that was expected. 160 now. My extrusion is really failing, but we're testing mechanical resistance. Oh shit, I did a whole 10% more instead of 5%. 170. Will we get to 800? I don't think so. But let's see what happens. Alright. Remember, we started at 400. Alright, extrusion of course is failing. Okay, it's holding. It's holding. Alright, that doesn't matter. We just want to see where we skip steps. Whoa, we almost, let's double check the temperature. It's fine. They say that if it burns, you're over 60. Actually, 60 should be the temperature where your skin is comfortable, like hot enough to touch. 60. Over 60, it kind of like feels like it burns. So we shouldn't be over 60 with the motors. All right, there you go. This should be 800. Quite a lot for a Prusa or for a bed slinger. Execution. It's failed mostly. Alright. Let's take it to the limit. I don't hear the pitch changing. So I don't think, maybe it's the limit that it can go with that acceleration. It won't go any faster, I think, because it doesn't matter how much. If I change, it doesn't change much. I don't hear the pitch of the motor changing. But it's holding fine. I think it's an acceleration thing, because it doesn't matter how much I move it, it doesn't seem to be capable of going any faster. So actually it's just acceleration. Maybe we'll run an acceleration tower next at 600. See what happens. Alright guys, so what we're doing right now is we are starting a print at 600 millimeters per second, and then we're going to start acceleration at 3000, and we're going to move in increments of 500 every 5 millimeters. So this is not the same print as the acceleration tower or tuning tower. It's actually, what we're doing is my test print, the same for the speed. But just want to see where how far we can push the acceleration before it starts to skip steps at 600. If we want, we can start from there, increasing the speed by using the screen, the LCD screen, but I don't think that's what we're gonna be doing. So we are starting with the brim at 120. So this is this is our test. Should be printed at 600 with 3000 acceleration now. As I said before, I know the extrusion will fail. I don't care much about that. Alright, actually I was at 60% speed. So now we're gonna push it back to 100 to see if we can get to that 600 that we did before. Alright, now we're at 600. That's it, 600. 3000 acceleration. There it is. Now with acceleration went up to 3500. That's it? That's too much. Alright, there we go. We failed. Alright. So we can do 600, but no more than 4,000 acceleration. We started to get problems, so I think that's the limit. I'll just move this up. I don't know if maybe we can move up the amp is supposed to be good for at 1.2. The driver should be up to 1.2 amps, and that will give us, we are at 1 amp right now, but I think that's enough. Actually, I had the motors, before putting 2 of them, I had it at 5.5 amps with 1 motor, and it didn't get too hot. It was good. It got hot, but not too hot. So actually we could do 0.1 amp more, but I don't think that's going to be much of a difference. Maybe what I can try next is maybe staying at, what I'll do next, I'll stay at maybe 500 speed, and then we can just check how much acceleration we can get with that. We're gonna do it in shorter steps this time, just not to wait so long for every step. Okay, this is the third, not the third, maybe test, but last test for today. So what we're gonna do now is we're gonna go, I put the driver at 1.1 amp for the 2 motors. I left the print speed of the G code at 500, and then I did acceleration. We start from 3000 and we move up in a factor of 500 every 2.5 millimeters, and it's the same print. Let's see how it goes. So let's see how this moves. I think with the heavy mass of the bed, now we are having more problems with acceleration than with speed. Of course, they're combined is the thing, but you know what I mean. Just the limiting factor is becoming acceleration and extrusion, of course. But I will get soon a high flow nozzle, and then when I get the nozzle, I'll do a video where I do the entire thing, like pressure advance and input shaping and everything. I also did some rubber fit, trying to dampen a bit the vibration. So I'm working on doing better ones, like with more dampening, like softer but not so soft that they collapse. But I don't want something so big either, so I'm trying to do something in TPU. So I'll work on the fit. I'll wait for the nozzle. Maybe once I get there, when the final version of the SteathBearner releases, I'll do that too. At least I think I'm gonna have it printed reliably, like in normal speeds. Maybe I can, before I was printing, I think that's 350, like a fast setting that I had. Now maybe I can try to get everything to 400 until I'll get the new nozzle. Alright. Alright. So set is set. So extrusion seems to be fine. We're doing 500 and 3000 acceleration. Alright. We are already at 35,100 and we're about to move. Alright, that's it. Now we are again at 4,000 acceleration. Seems to be holding better. Extrusion is holding up, but just barely. I don't know if this is gonna be too much light. You can see better there. That's 4,500 now. So my aim is gonna be try to get it at printing at 500. That I think is pretty fast. Let's see how reliable I can get it. And if not, I'm gonna move down from there in speed. We're about to get to 10 millimeters. That's it. 4,500 is the, I mean, with this setup and this amp is as fast as we can accelerate before skipping steps. Not bad, not bad. I know that it's not many prints where you're gonna be able to take advantage because the acceleration limit. I mean, get to that 500 speed, but still, maybe it's a big print. It's gonna be very useful. Okay, that's it. Bye guys. Take care.